So I wanted to finish with just two things actually. The second one, I start with the second one, and it will be the end, like the fireworks, the best for the end, will be the fractal geometry, because we can't talk today of space without, and especially space and infinity, without mentioning Mandelbrot work on fractal geometry. But first, I think you remember that I said that there is this debate, even controversy, like people really were fighting. The substantialist on one side to say what is the very nature of space, and at the time when you say the very nature of space, it was what is the real nature of the real thing, what is reality. And on the other side, the essentialists, like the mathematicians, the geometrists, the people that think that they are in the genealogy of Pythagoras or Plato, etc., etc. And what Leibniz found, actually, the way for Leibniz to solve the problem, and I think, but he never said that, but I suspect it is because that he actually invented this very famous concept of the monad, in my opinion. Because in my opinion, when he made this concept of a monad, that was to overcome this opposition between atoms on one side, what is reality? It's just atoms on like discrete part, and on the other side, that's just properties that are universal properties, and it is not. It's in a way, it's a position. It's not an atom. Like a position is determined by its theoretical properties, and not by a substance, something that is actually a mass, or I don't know. And in a way, what say Leibniz, if I can, because with Leibniz it's always very tricky, because sometimes you think he's a determinist, but in fact he's not, in another level, because he's just so
right.
It's very tricky. And some people, they use Leibniz to say everything is determined, but really, it doesn't what you mean. It depends on what you mean by determinism.
Yeah, no, he has this notion. What is it? That there's this, everything is for a sufficient reason. There's this,
yeah, exactly.
But things that are not deterministic is an infinite chain of causes that only God can perceive, but we can't. So that's a way to have determinism and non-determinism simultaneously. Leibniz is subtle.
Exactly. And when we say that, there is something even, if I can allow myself, even deeper than what you said about the fact that it's only God that knows it. Because the way God perceives things or knows things is not our ways. So God, the way he perceives things is more, it's not even determined, not even for him, because it will limit him. And so that you know what I mean? It's just even, the perception of God is not a limited perception. What he perceives is not something that put us in jail in itself. But anyway, but the reality is that grab things. But the idea of monad, that is not talked too much nowadays. When people are interested in Leibniz, they don't talk that much about the monad, because they say they don't understand the fact that he said that everything is pre-established, and so the monad is related to the entire universe.
No, but the reason for that is, how does the mind isn't physical, so how can the mind affect matter? And
you
the
see
pre-established harmony.
You see that your mind is working so well this morning, because it was there that I wanted to go.
Okay.
And you are already there. You
okay.
see that? You have the eye of God, because you already know where. it's just going. Exactly. Your mind is going so fast.
No, and Leibniz is wonderful, because he always sees ways to combine views that people think are contradictory. He sees good in everything. And he's able to make a system. For example, he was trying to combine Protestantism with Catholicism and reunite. I mean, but
exactly. Well, that's the reason why one of the philosophers that inspired the most, that was his philosopher, it's Hegel. Hegel was inspired by Leibniz, because in his way to overcome contradiction. It's part of the thing. But it's another story. I don't want to enter into it. Maybe we'll talk this afternoon about time. We will talk about Hegel, but in a different way.
Fascinating.
So the idea is that, he said that the windows are closed in the monads. Because he said the monads are, it's like if they are, if we talk about information, they are informed about everything, but they don't have windows. So they are not, there is, and so it sounds some kind of absurd. It's because the monad, in a way, it's my interpretation, so you don't have to. It's the relation itself. So the relation itself doesn't need to be related, because it would be related to a relation. So everything is a relation. So and it will help to understand like why you try to find, when you try to find a substance, because you have this idea that you will find something discrete, you don't find a substance. You find something that is wave or something, etc. Mm-hmm. But that means everything, and it will be taken, it will be used by Whitehead, is actually the main thing, or if we could use the word, but just as a metaphor of a substance, the substance of the world is actually the affection, the fact that you are affected and you affect.
Are the relations, not the objects. The objects disappear.
Exactly. But the relation is actually the reality of the real of the thing. But we think, no, to what is it related? But it is related to a relation. So and so the basic idea is like we need to understand a monad is some
category theory is like that, by the way.
What?
Category theory.
Oh, that's like interesting. That. Because it's actually what is about process philosophy in Whitehead. It's like the substance is the process. And so the monad is the fact that something is affected by the entire universe and affect the entire universe only, and it's interesting the idea, only because it's located in a certain place. The very fact that it's located in a certain place, right away, it's already different from everything else, and in the same time, it comprises in itself everything else. But because it's in a certain place, and that it's the only one to be in place, in this place, and that has influenced also Husserl and phenomenology, it has a unique perspective of the entire universe. And the perspective that it has on the entire universe, it what makes it in itself being singular. Because nothing else can have the same perspective. Even if you have two people or two things that looks absolutely industrially made to be the same, right away they are not the same, just because they have a unique perspective on the entire world. They are affected. And so how is that possible? He said that's possible in a way, and that's when the mind enters into things. It's that when we think about interdependence, like when we talk about interdependence today, we think about interdependence in space, like different bits of space that touch each other at the end, and so like ecosystem and all that, etc., etc. But he goes much further. He said that is an illusion. It's just an illusion. It will be very contemporary. They'd say that's an illusion, like space is an illusion. This idea that it's because it's inside the monad. But even when you say inside, it's not really inside, because inside means it's in a space that will be inside, but it's inside without being a space, the monad.
In the mind.
Exactly. That everything is already related in a unique perspective. So that means, that's the point. So that means you don't need to have the windows open because it's instantaneous. It's a perspective, but it is it's immediate. It's the only immediate thing. So we could say in a human being, it will be pure intuition. That it's not something that, but every time you open the windows, it's an illusion when you think you see something or you're relating to something else. But in fact, it's just at that time that the veils of the illusion of space are putting each other in front of each other. I thought it was interesting to say that. Because doing that is actually overcoming all the paradoxes of, on one side, it's just property, but seems to be empty of any substance, and on the other side, it's substance, but the substance you can still divide, and so it's never the real substance. And you overcome that saying, because you were not looking for the real thing. the real thing is.
Yeah. Well, the monadology is a late work by Leibniz, so it's very dense and very subtle.
It's so beautiful.
Yes.
Small book, but I mean.
Yeah, I don't know if you know that the great logician Kurt Gödel basically stopped doing all his research just to devote himself to studying Leibniz.
I know.
And there was no way to convince him otherwise.
I understand. I can understand that. When you read Leibniz and you really want to understand it, you don't stop with all the prejudice that people have of Leibniz thinking they have understood it because they... No. It's just so deep. When you read the monadology, I mean, I've read it maybe more than 10 times, and I still, in some of the proposals, I still think, oh shit, I hadn't seen that. And it's just,
you know, it's a miracle that any of this survived, because they were basically copies of letters he sent to people or notes to himself. And the ink is fading. They buried it underground. It survived the Second World War.
yeah.
And to be able to read it, Leibniz's handwriting is not the easiest handwriting on earth to read. So you have to have learned Latin at a very early, or French at a very early age, so that you can decipher the scribbles. And it's really scribbles, because Leibniz writes on the margins. He puts notes here and here and here.
Yeah, sure.
It's not a linear text.
Yeah, of course.
So when people try
He's not a linear person anyway.
Right, so when people try to go to the unpublished manuscripts, the Nachlass was, I don't know, 200,000 pages or something. It's this total mess, and you have to try to disentangle things and extract things. It's a challenge.
Thinking about maths and the idea that things are multiplied on one side and on the other side, I know you already know what I'm going to talk about. Benoit Mandelbrot, fractals. Your friend Benoit Mandelbrot. Yeah. So what about his idea about infinity of space? Did he think space is infinite or not? Or did he have a...
Yeah, well, I think one thing one has to credit Benoit with is bringing geometry back into mathematics, bringing diagrams, illustrations back into mathematics. And I think...
So it's back to the origin, back to geometry.
Exactly.
To the origin of mathematics, as we said at the beginning of our dialogue.
Bourbaki had prohibited diagrams. And then comes Benoit Mandelbrot, and his work was all geometrical intuition. He doesn't even have conventional proofs for a lot of things.
Oh, that's wonderful.
So he worked with geometrical intuition. And
like you, as you said, he envisioned forms in space. And so he's a mathematician of space.
Yes, and his books are full of beautiful, fascinating illustrations. And I imagine that they created a revival of geometry among young people. I hope they created a wave of interest in mathematics. At any rate, they were art books, mathematical art books, you know, and they're even good for mystics. I remember listening, I think it was some Sufi music here at this university, and they had something receding to infinity, going on and on and on. And that's what you see with the fractals. Yes.
So fractals are infinite?
They go on forever. The Mandelbrot set has infinite number of copies of the Mandelbrot set, smaller and smaller and smaller. And each Mandelbrot set has little buds which are other Mandelbrot sets, which have other budding Mandelbrot sets. And you can keep going forever without limit into this.
But it's forever with the same forms repeated, or forms that are always different and always differentiating themselves?
Well,
because that is very important.
The Mandelbrot set contains an infinite number of copies of itself. They're all a little bit different.
But a little bit is a lot.
Okay, if you like, but they're recognizably Mandelbrot sets, though.
Yeah.
So it's like a tree that you have, you have buds. You have a leaf, and you have buds, and then you have buds on the buds, and buds on the buds on the buds. And
so do you think that...
It looks very organic.
Exactly, it's what I was...
Very biological.
So is it a copy of reality, or is it a description of what actually is the real thing.
Well,
of the universe.
that's an interesting question. I see it as a Platonic ideal of biological forms, like the lungs or the circulatory system has a fractal. Fractals are the right geometry for thinking about these branching structures which have things on all different scales. You know, as you magnify it, a piece looks a lot like the circulatory system, or a tree. You know, from a distance you see something. As you get closer, you start seeing more details, and then more. And so Benoit came up with a geometry which is closer to biology, to organic growth.
Does he have the idea that, I come back to my question, I'm sorry, that the universe or space is infinite or finite?
Well, the Mandelbrot set, certainly you can go with a microscope zooming into the Mandelbrot set forever and ever and ever.
So it's infinite. So if we're able if we're able in space to figure.
It's infinite complexity, yes, in space.
But if we're able in space to figure infinity, that means a fortiori that the universe is infinite. Because when we are figurating it, we are figurating it basically in the space that is here.
Well, Benoit's imagination is infinite. The mathematics of fractals is infinite. Whether the real world is infinite or not, I don't know. But you know,
but when you're looking at it, you said you can look forever. But if you can look
zoom
forever,
in with a microscope,
but when you're zooming, what does it zoom?
Find smaller and smaller details.
But it's in our space. You're looking at it on our space when you're figuring it.
It's a geometric fantasy.
But it's here. It's not in the mind. It's something that you do figure. You figure.
Well, I don't think it has physical reality, because if you zoom in on a Mandelbrot set, you can be zooming in below the size of atoms. You know, as you magnify more and more and more.
I know, but still.
And you keep finding the same structures repeated more or less along. I think one of the beauties philosophically, I think, or artistically of the Mandelbrot set is, you know, the notion of infinity. In mathematics, there's Cantor's theory of infinite sets, which is very beautiful and tremendously imaginative. But it's not visual. And what Benoit gives us is a geometrical representation of infinity. We see it, there it is. You know, there's this infinite geometrical object that has infinite amount of detail, more and more detail. And it's very beautiful because it connects more with the forms we see in nature. As Benoit points out, he reinvented geometry. It's amazing that a thing like this could happen.
But if it connects more with what we see in nature, maybe it is the best description of nature itself. So maybe that shows us what is nature.
Well, it's a good approximation. It's a good Platonic ideal, perhaps, of the forms we see in nature.
At least it shows the direction.
As Benoit points out, you know, in Euclidean geometry, clouds are not spheres. You know, mountains are not pyramids. The geometry he discovered is the geometry of naturally occurring forms. Now, they're Platonic ideals of those forms.
Even it's not only the actual form, but in the form, it is the form actually processing themselves. Because it's the way the form are born out of other forms that it shows, isn't it? Because when you were talking about biology, that's actually it.
Yeah,
it's like we could say if we invented a word. I love to invent words like the philosopher. We always do that. We could say like genetic geometry or something like that. You know?
Organic geometry.
I like the idea of genetic because it's genesis.
Yes, that's very good. Yeah, absolutely. No, it's a miracle, and this is because I think Benoit attributed his success to the fact that he was in hiding in Vichy, France, perhaps it was. Mm-hmm. He didn't have a conventional education, and he developed his geometrical intuition. He was not a conventional mathematician. Some very fine mathematicians have struggled to prove things conjectured by Benoit. Benoit really relied on his physical and intuition. And he created a whole new geometry, the opposite extreme from, you see, Euclid's geometry is this Platonic ideal of God's thoughts. It's totally inhuman, the forms that Euclid studies.
And you could say it's even unbiological.
Totally unbiological.
Yeah.
They're archetypal geometrical forms like nothing that we see in nature. Whereas Benoit's fractals have this intimate connection with all the forms we see in nature, biological or geological.
And so in a way, that's a way to talk about infinity, not as something that will be static, but infinity as being non-finite, like always in motion, like not closed
it's growing.
on itself.
It's in statu nascendi, Benoit's fractals. And the other aspect is that, what did I want to say? How would I put it? I lost the train of thought. You see, it brings mathematics closer to us, to biology, to the forms we see in nature.
Yeah, and I think it's a very good, in a way, it's a very good transition to our talk about time, because time is about motion, as we will see this afternoon. And you see, we started to talk about infinity in a very abstract way with Plato, and now that we are with Benoit Mandelbrot, we see that in order to have a certain idea of what is infinity, a concrete idea, if we use Benoit Mandelbrot, as you said...
As you zoom in on the Mandelbrot
and the zoom is what? A motion. Because actually, you do, and so it's either your stare, that is creating something that is looking at...
Well, any little piece contains the whole thing.
Exactly, and the little piece is... But it's the very process, infinity is the very process of either observing or creating something all by itself. That is the process, the creative process itself. So we need to introduce time even to understand what could it be for space to be infinite.